Howdy Hawks, it's Logan here with today's lunch options. Today we have chicken sandwiches, beef tacos, turkey chef salad, cucumber slices, and broccoli. And because math testing's coming up, we have a couple of math videos to keep your skills sharp. Bye!
Thank you for joining me for this math moment. I want to find out if you have some vocabulary we need to work with circles. If I measure all the way around a circle, like if I put a string around it, and then I stretched out that string and measured it, what would I call that measurement? Well, that's called a circumference. Circumference? Is that what you measured if you were putting a fence around a circular yard? Circumference is like a little raised crust piece around the edge of the pizza. What do you suppose we call this part, the inside part? Like the cheese on the pizza, or the grass in a circular yard. What do we call that part? That's the area of the circle. So that's an area. Now, we can have a piece of circumference. Imagine if I took that like pink string and I cut just one little piece of it. That's a piece of circumference. Do you know what that's called? That's called an arc. Now, if I took a piece of this circle, like a pizza slice, you know what we call that? If I shade it in, that would be the area of a sector. What you need to know is that there is a special relationship between arcs and circumferences, and areas of a sector in areas. In other words, each of those things is a place of some kind of whole. So, for instance, if you had a circle and you had some sort of central angle here, like 50 degrees, we would say that we can make one fraction that's all about degrees. That 50 degrees is a piece of all the way around degrees, which would be what? Yeah, 360. That fraction will actually be equivalent to the measure of the arc over the measure of the circumference, likewise, the central angle's degree measure over all the way around a circle's degree measure will be equal to the area of a sector over the entire circle's area. This will be key in solving any problems where you're looking for the measure of an arc or where you're looking for the area of a sector, because first you'll find the circumference if you're looking for an arc. And if you're looking for the area of a sector, first you'll find the area of the circle. And then you'll just let x be your unknown up in the numerator. And then do a little bit of cross multiplication. Thank you for joining me for this math moment.
Alright, today we're going to find the area of a shaded sector, and we're going to round to the nearest hundredth place. Well, first of all, we have to understand that the area of a sector is a piece of a circle's entire area. So we're going to set up a proportion where we compare pieces to wholes. Proportion again is a fraction equal to a fraction. We're going to make one fraction all about areas. We're going to make the other fraction all. How many degrees go in this particular sector? You can see in the drawing here, it's 50. What's the whole number of degrees all the way around? It's 360 degrees. Going to take 50 over 360 and set it equal to the area of the sector. Well, that's what we're looking for, and we'll call that x, and then we're going to find the area of that circle. We have the formula for that. If we go to our reference sheet, the area of a circle is pi r squared, and with r being the radius. The radius in our circle was 8 inches, so we just plugged that in. 8 squared in our head or on our calculator is 64, and the pi, the rational number, always comes to the rational number. So the exact area of our circle is 64 pi square inches. I'm not going to worry about the units right now, and I'm going to pull that exact number, 64 pi, there for now. Now, since it says round to the nearest hundredth place, eventually I'm going to use the pi button. But first, I'm going to cross multiply. I'm going to say, hey, what's 50 times 64 pi? Well, 50 times 64 pi is 3,200 pi. Then I give the butterfly a body, and then I give the butterfly another wing. We get 360 times x is 360x. To get x by itself, since 360 is being multiplied, we'll divide both sides by 360. Now, if I wanted an exact answer with where I was leaving it in terms of pi, I would use the ABC button. I would do 3,200 ABC, 360, and then I'd eventually get a mixed number. So then I'd have to hit a second function in ABC, and whatever fraction I got, I just put right in front of pi. But since we want an exact answer on this one, we'll actually take 3,200 times pi, divide by 360, go ahead and try that. And you'll see that you'll get 27.925626. Now this one said round to the nearest tenths, so we have to know which ones are our places here. So the whole number is part to the left of the decimal. That's the whole number. The next digit is the tenths, and then the next digit after that, 2 digits over from the decimal, is the hundredths place. I like to underline the one I'm after the hundredths place, and then I circle the next one. I call that one the decider, because if this is 5 or bigger, this digit jumps up 1. If it's not 5 or bigger, this digit stays the same. Since it's 5 or bigger, we're going to say that x is approximately equal to 27.93. And that would be square inches. And that's our final answer. Thank you for joining me this math.